Now we come to a part of Chapter 3 in which we go back to conversions. In Chapter 3, we're covering what a mole is. Now, some people often are taken aback by this word mole because they don't know what it is. But mole is a number, just like dozen means 12. Mole actually just means a number, and the number is right here, 6.022 times 10 to the 23. It's often written as 6.02 times 10 to the 23. It's called Avogadro's number, and we use this really large number. You have to remember this is going to be 6 with these, it would be 6022 with 20 more zeros after it. So it's a huge number, one that you can't possibly conceive of. The reason we use this number is it helps us to count atoms. Atoms are extremely small, and so we need a really big number. Just as counting eggs or donuts in dozen makes sense because you usually have a sizable number of them. When we look at atoms, we have a really huge number of them, even in a tiny, tiny sample. And so using this big number helps us to count them. So you can write that mole is equal to 6.02 times 10 to the 23. And this is our conversion. This is our equivalency statement that we can use to make conversion factors. We use mole when we're counting particles. So it's going to be, we can use mole with atoms or with molecules, but we can't ever use the word, the number mole with grams. That doesn't make any sense. It's way too large. That's like the size of the Earth, or maybe even bigger. It's absolutely humongous. So a mole is 6.02 times 10 to the 23 items. So if we have a mole of carbon atoms, that's going to be 6.02 times 10 to the 23 carbon atoms. If we have a mole of water molecules, then it's that many water molecules. If we have a mole of vitamin C molecules, it's that many molecules. That's how simple this is. So we can write conversion factors from an equivalency. If we have a mole and we're considering atoms, then there's 6.02 times 10 to the 23 atoms. Or we can flip it over like we learned to do with our other conversions. So to use a mole, we can take a number of atoms and say how many moles that is of that atom, those atoms. All you have to do is use this conversion factor that 6.022 times 10 to the 23 is equal to a mole, and flip it over if you need to. You choose the one that gives you unit cancellation. So here's a problem using this. What is the number of moles in 2.4 times 10 to the 22 atoms of lithium? So we start with the given in the statement, 2.4 times 10 to the 22 atoms. So we have 2.4 times 10 to the 22 atoms, and you can put lithium or of lithium, or you could just use atoms. And then we use a conversion factor that gives us cancellation. Atoms cancel with atoms to give you moles. You do the math, remembering to enter this in your calculator as 2.4 times 10 to the 22 by using the EE key. And we use the 6.022 times 10 to the 23 by using the EE key. And it'll give you 0.0040. If you have any doubts in how to use your calculator, notice that for each of the problems in this online video that I do with you, I'm going to have a video of me using my calculator to get the answer so you can see how to enter this in your calculator. So you'll see another video posted on that. Okay, so now you are going to try to do these problems. If you feel uncertain with your calculator, go ahead and stop this lecture and look at the lecture on how to use your calculator on that last problem so that you know how to do it. Okay, so how many atoms are in 2.89 moles of aluminum? Go ahead and try that problem. And then after we finish that, try this problem. And how many moles of helium is in a balloon containing 7.2 times 10 to the 22 atoms of helium? The first thing we do is we start with 2.89. We're going to have to make sure that mole cancels, so mole must be in the denominator, and we want to go to atoms. Remember that 6.022 times 10 to the 23 never goes with mole. It always goes with atoms. If you have any trouble with that, just write mole equals 6.022 times 10 to the 23, and you can say mole of atoms is equal to 6.022 times 10 to the 23 atoms, and use that to construct your fraction. So we do this math, and you come up with 1.7 times 10 to the 24 atoms. Okay, how many moles of helium is in a balloon containing 7.2 times 10 to the 22 atoms of helium? We start with our given, and we orient our fractions so that atoms cancel, and we go to mole. Remember that 6.022 times 10 to the 23 belongs with the atoms. It never goes with mole. We do our math, and we come up with 0.12 mole. So why is this mole important? The reason is that we have defined 1 gram as being 6.022 times 10 to the 23 AMUs. Remember, we weigh atoms in AMUs. 1 gram is equal to a mole of AMUs because that's what this number means. If we have a mole of hydrogens, we've got a mole of 1.00797 AMU. I'm getting this number, that's the atomic mass of hydrogen. I'm getting this number from the periodic table. This, I can replace the word mole with 6.02 times 10 to the 23 times the atomic mass of hydrogen, and 6.022 times 10 to the 23 AMU, well, that's a gram. So when I have a mole of hydrogen, I have its atomic mass in grams. So I can actually weigh out hydrogen atoms by counting out that many grams, which I can do on a balance of hydrogen. A mole of any element is always going to be the atomic mass in grams. So if you pick out any kind of element, we'll get a periodic table right here. And if you look, if I have a mole of aluminum, what will it weigh? Well, you look at the periodic table and you see that the atomic mass is 26.98. So a mole of aluminum is going to weigh 26.98 grams. So 1 mole of an element is the atomic mass in grams. And what we do is we call this the molar mass. So you're going to hear me use this term in the future. I'll say, so what's the molar mass of something? You know that you just need to go to the periodic table, get the atomic mass, and express it in grams. We can make a fraction out of this equivalency that the mass of a mole is the molar mass. So 1 mole is going to be equal to the atomic mass in grams, and we can create a fraction like this. Here's an example. If I have 0.004 moles of lithium, how do I figure out the mass? Well, I look at the periodic table and I find that that is the atomic mass of lithium. So I can go from mole to gram, and the atomic mass of lithium is the number of grams. I do the math and I come up with 0.028 grams of lithium. So now what I want you to do is pause and do these problems. Okay, how many grams of calcium are in 0.2 moles? We're starting with 0.2 moles, and we know we're going to go from mole to gram. I look to see what the molar mass of calcium is, and I see that it's 40.078. And I do the math, and I come up with 8 grams. Now, some of you are probably looking at this number and saying, why couldn't I just write 40? We usually don't express our molar mass with any less than 4 digits, and if that's what you want to use, that's fine. If you cut it off 4 digits, you're just making your calculation less accurate, less precise. How many moles is in a 5-gram block of iron? We start with the given 5 grams. We're going to convert gram to mole, so we look up iron and we see that its molar mass is 55.845 grams. You multiply through. Remember, if it's in the denominator, you divide, and you get 0.090 moles. How many grams is 250,000 atoms of gold? Here you might have struggled a little bit here because you were saying, I don't know how many atoms are in a gram. So what we have to do is use the relationship that we know. We go atoms to mole. We know a relationship there. And then we go from mole to gram because we know a relationship there. A mole is always going to be 6.022 times 10 to the 23 atoms. And for gold, which is the symbol AU, you look up 197. You look on the periodic table and you'll see it's 196.97. I do the math and I come up with 8.2 times 10 to the minus 8. So this is how you can think through a problem. Number always goes to mole. This is a number of atoms or a number of molecules, always goes to mole, and mole can go to gram using the atomic mass in grams. So here's an example of how you would use this. If the problem gives you gram and you need the number of atoms, you know you have to go gram to mole and then to the number. If mole is given and you need to go to grams, you can see it's a one-step conversion that you can do directly. It's really helpful to write this down while you're first starting to figure out how to do these problems so that you can keep in mind what the relationship is between the units. What about compounds? Well, 1 mole of water is made of 2 moles of hydrogen and 1 mole of oxygen. So I know the mass of 2 moles of hydrogen. I just use the atomic mass. And I know the mass of 1 mole of oxygen. I can look on the periodic table and see it's 16. I add that together, and that's going to be 18.02. That is the molar mass of water. So I can write 1 mole of water is 18.02 grams. And we'll say that the molar mass of water is 18.02 grams. This unit map holds true for molecules and for atoms. It's the same unit map. So if I were to give you a number of molecules, you can convert that to mole and then go to gram using the same thing, that 6.022 times 10 to the 23 molecules are in a mole. And then the molar mass you get from summing the atomic masses of all the atoms in that molecule. So how many molecules of carbon dioxide is in 2 grams of the compound? This is our starting point. Using the unit mass, you would see you have to go gram to mole to molecule. What do you use? You use that 1 mole is equal to 6.022 times 10 to the 23 molecules, and that gives you this fraction. And you use 1 mole of carbon dioxide is 44.01 grams. So 2 grams, we convert gram to mole, and then we convert mole to molecule. So that gives us 2.7 times 10 to the 22 molecules. What is the mass of 0.5 moles of sulfuric acid? I figure out the molar mass of water by summing up all the atomic masses. It's 98.09 grams. Because I have mass and I'm wanting to go to mole, it's only one step, mass to mole. So mole to gram using the molar mass of sulfuric acid, and I get 49.04 grams. So now you go ahead and you try to figure out this problem. A package of equal has that many molecules of aspartame, and this is the formula for aspartame. What is the mass of this amount of aspartame? First thing we do is we write 3.2 times 10 to the 20 molecules.